Hi. So as I was writing this application up and talking about some of the work that we've been doing with the agricultural robot and with machine learning and with embedded vision, I thought it actually made quite an interesting little case study as to how to do it. So I spent a little time this weekend and I've actually created a set of step-by-step instruction guides that you can use if you wanted to recreate or get going with a similar application and a similar project. So with that in mind, I've created these steps. I'm actually going to walk you through it as well because it doesn't take too long to do. It's nice and simple. It's nice and simple to do, and I think it's a good project for us to actually take a look at and get working with it. So what I'm going to do, the first thing we're going to do is we're going to go to Kaggle and we're going to download this agricultural crop data set. Now, if you've got the instructions, which are linked in the blog, there's a link direct to this data set. And then what we can do is we're going to download it. Now, you might need to register for an account. I registered quite simply using an account. But if we click on download here, then we can download this. I'm actually just going to save this to a slightly different area. I'm going to save this to an area that I've set aside for just doing this demo. So I'm going to download this and save it into my downloads, into a specific area that we've got on that I've set up on my drive to download that. That'll take a few seconds to download. Once we've done that, what we want to do then is we just need to go there and extract the data set. So we can, if we open up the directory that we were just working in, we'll see that we've downloaded the archive file here. And if we extract it, so I'll extract files to archive, it'll take a second or two. But then under there, you'll see that we have all the crop images, the different types of crop images. You'll see some more. You'll see some more images, and they're all nicely sorted for what we want to do today as we're working through this. So now that we've done this, what we want to do is we want to create the actual Edge Impulse project. Now to do that, we're going to go back here and we're going to go back to Edge Impulse and log into the Edge Impulse Studio. So if you don't have a username or an account, you just have to register and set one up. It's really simple, really quick and easy to do. I do have an account and username, so I'm gonna log in. And you can see I've already tried this a couple of times. I have a few other projects that I've worked on previously as well, but I've got this one. So we're going to create a new one, and we're going to call this S Friends Demo. And we're going to click Create New Project. I tell you to create a slightly different name in the examples, but it's all the same. Once you see that, we'll see that we have the project created, and we're going to click on OK. Now this point's really exciting because it asks us to connect in an Edge Impulse system into an Edge Impulse and to begin to gather some data. And how we want to do that really depends upon what we want to do with our project. So what we're going to do is we're going to tell you that we actually want to do a CNN, so we want to do some image classification, and that we want to classify a single object. So we want to use a small low-powered microcontroller for this application, as we're talking about, and we don't really want to classify multiple objects. So we're going to classify a single object. So this is what we're going to do. So we're going to click on that, and at the moment we don't want to. I'm not going to connect to development board at the moment. We'll do that in a little while. But we do want to import existing data. So that's what we're going to do. That's what we're going to do next. And we're going to import existing data by going to the uploader. And once we've gone to this uploader, what we're going to do is we're going to let the tool automatically split the data between the training and the testing site. And then we're going to go to the choose files, and we're going to navigate to the area on our computer where we've just extracted the data set to. What we're going to do is we're going to go under the CAG2 directory. We're going to pull in the wheat images, and we're going to select them all. We're going to click on open, and we're going to give these a tag, although they're already tagged. We're going to give these a tag of wheat. We'll put W in there, and we're going to click begin upload. And you'll see it begin to upload. It's really quite quick to upload. So we're going to do that for wheat. I'm going to do that again this time we're going to do that again for the maize ones that are in there. Although this time we're going to do it the tag of maze, and we'll do that upload again. And then finally, we're going to do I'm feeling adventurous today, so we'll do the sugarcane ones as well, just because it can look a little bit lightweight. So it's interesting to see how they are different. We'll do that sugarcane, and we'll begin the upload as well. Once we've done this, we should be able to go then to our data acquisition, and we'll see that we've got a number of elements that have been uploaded. We have some labels as well, so we've got 3 types of labels, and we can see all the files. And if we click on a file, we can see the element that we have and what it actually is. If we want to record new data, we can connect over our system, connect to the Sony S-Fence, and we can build it through in that direction. Now what we're going to do now is we're going to actually build the impulse. So we're going to click on impulse design, and the first thing we're going to do is we've got an image size, and we're going to say that we're going to crop these to be 96 by 96 images, and we're quite happy with that for the time being. We're then going to click on add processing block, and we're going to click on the image, so we're going to add the image processing block. And then once we've done that, we're going to add a learning block as well. So this one we're going to do a transfer image, so it's essentially a pre-trained image classification, and we're going to add that one on there as well, because this is really ideal for working with image processing. Once we've done that, we'll see that we have 3 outputs in our system. We have maize, sugarcane, and wheat, and we're going to click on the save impulse here. Now as we've saved this impulse, what we need to do is go through and configure it ever so slightly. So we're going to click on the image impulse here, and we're going to configure that as well. But before we do that, actually, what we're going to do is I'm going to go back to the dashboard here, because as we're configuring it, what we want to see is the terms of the performance, the memory usage for our particular target board that we're trying to target. So we're just going to scroll down here on this dashboard here. You can see that we've got some data collected. We've got no devices connected yet. And what we're going to do is we're going to change this drop-down menu here for the latency calculations from the Cortex, and we're going to select the Sony board here as well. And that just makes it nice and simple. It means that all our calculations, all our memory usage, our latency estimations, it's all going to be aligned with the boards that we're developing and working for today. So what we're going to do is we're going to go back to the image tab here, and we can see that we can see that we've got some images, and we can select them as we want from this list. We're going to leave the color depth at RGB for the moment, and then we're going to save the parameters. Now, once we've saved the parameters, we're going to generate features. And this is just going to run through and generate the features for the images in there. And hopefully it's going to do that pre-processing there and create the important image features that are going to be used by the neural network. This will take a few seconds to run through. And once we've done that, we are going to then try to train our neural network, and hopefully it shouldn't take too long to do at all as we do that. It takes, as you can see, it's relatively quick, and you can see here it's giving us a little bit of performance time on our board of about 5 milliseconds and about 4 kilobytes of RAM, which is fairly good, as we'll begin to see. So we're going to then click on the transfer learning, and this is where we're actually going to train the neural network to give us the performance that we want. Now, initially, we're just going to leave everything as we want to. We're going to select start training, and this is going to run through, and it's going to start running through and doing the training of the neural network. You can see we're going to do 20 cycles here. We've got a learning rate that's relatively low, so as we don't begin to overfit, and we've got a confidence rating as well of about 0.6. And we'll see this begins to run through all of the training epochs and gives us an accuracy and a loss rate as we run through there. So it's all nice and simple, all very simple to do so far, and nice and easy. And remember, we just picked up that data set. We did a little bit of research into it and found that data set. In reality, you may want to gather your own data or do your own data set, and we may want to augment it with different types of crops or weeds, depending upon what sort of plant classification that we wish to do. Now we can see it all running through. It's continuing to do its training, so it's running through nice and quickly. It doesn't take us too long to actually create these models, which is really good. And it's another great example really of how we can deploy it and how we can get it using up and running and working quite quickly. Once we've done this, obviously, what we're going to need to do then is we're going to need to do some validation and checking that our model is working as we would like it to be working in the field, not only with this trained data, but also with the live data. And of course, we want to be able to deploy it onto our Sony board as well to make sure that we're seeing the right performance. So this shouldn't take too long to do, and again, it's very quick, very simple to do. And actually, as I said in the blog, the great thing about the Edge Impulse is when we come to generating that output, it'll generate as an application which we can use for testing and working with. It'll also generate as a simple C code netlist, a C design, and that C design obviously we can manipulate and modify with our GNSS algorithms, with our working with the SD card, and any of the other things that we want to do. We're going to need a Wi-Fi network on there as well, so we'll be adding a Wi-Fi network on there for the deployed version. So our model's still training. It's nearly getting to the end now. It's not hopefully it's not too far off. And then once that is, we can begin to, like I say, we can start doing some classification. And it's training now. It's changing that model from using a floating point model, which is uses floating point numbers, to using much faster integer 8 representation, which is much more suitable for working in small microcontrollers like we have with the Sony Esperance development board. The training is completed. We get the confusion matrix, and we can see that the accuracy is about 80%, which is not too bad, but it could be better. We see the flash usage and the peak RAM usage. We also see the actual estimated on device performance, and this is running about 3 and a bit seconds. Now that for a real-time navigation, if we're using it for that, obviously that's really slow. But actually, in this robotic application, it is actually acceptable, because what we need to do is we need to minimize the power of the system overall. And we will have several of these cameras running, and of course we need to, the slower the robot moves and the less energy we use, actually the longer the robot can exist and be deployed in the field. So that slow inference time is not a huge issue to me. What is a bit of an issue though is I think that the 80% for the accuracy is a little low, and that we could get it a little higher. So we're going to go through and we're going to do another iteration of this and change a few parameters. So what we're going to do is we're going to go back to the impulse area where we're going to create the design, and as opposed to fitting to the shortest axis when we resize the image data, we're going to squash the image data such that it all sort of scales down with the image. We're going to then click on Save Impulse, because we've made a change there. Then we're going to come to Image, and we're going to change these parameters from RGB to grayscale, and we're going to click on Save Parameters, and then we're going to generate the features again. So the RGB will give us a lot better implementation, I think, or I hope, this time round than it does if we're running through there. And it should hopefully allow us, once we've done this once we've generated these features and done the training again, it should generate a nice simple application that we can use. So we'll let this finish generating the features, and then we'll retrain the model. Okay, again, so it runs through fairly quickly. And now we can go to the transfer learning. We'll leave everything else the same. You'll notice this time that we've got an input layer with a lot lower number of features because we're working with RGB, not with sorry, we're working with grayscale, not with RGB. So it makes a much simpler input image. And what we're going to do is we'll start the training again, and we'll see what the confusion matrix looks like this time when we go through it. Okay. So when we've run through this and we take a look at it, it takes a few minutes to train again. So I paused the recording while it was training. But you can see this time by making these simple changes, we've got a really nice accuracy in there for our application, and a relatively low loss rate there. So I think this is a good set that we can start with and we can work forwards with to actually create to actually try this with some live classification and actually deploy it onto the Sony S-Bench and see how it works, and make sure that that time that we can see, that inferencing time that we see down the bottom, notice it's not really changed, is still is what it is, and that it's doing classification correctly on the system. So we can do this. We can try this really quite simply. We can go to the live classification, and if we want to, we can connect a device. For the time being, I'm just going to load a sample. So we'll just try one of the samples from the test sets that we've got. So we'll just at random, we'll pick a wheat one, and we'll click on load, and hopefully this should come through and tell us that it is wheat. If not, we'll have another issue. We'll have another look at it. But you can see it's come through, and it's relatively quickly come through and told us that it is wheat, and that it is picking up this, and it's looking really quite nice, I think, for this application. So what we'll do now is there's a few things that we can do actually. Now we're in a position that we think that the model is good. We've got a low loss rate. We have a high accuracy. We can run through this and we can take a look at it and try to actually see how it's going to work on the actual solution, on the actual board. And to do this is where it gets really exciting with Edge Impulse. And one of the things that you should have installed if you're following through the instructions is install the Edge Impulse daemon, and that allows you to connect from your development machine to your selected development board and work through that. And this is one of the things that we're about to start doing now, and start testing on the board. And to do this, actually, we're going to just do a little bit of cloning and get some and actually download the standalone example that comes with it, and get the code all up and running such that we can start working with it and we can start deploying it. So what we're going to do actually is I'm going to open a Git window, and then we're going to download the we're going to clone a repository that includes a lot of support for the Sony S-Bench board. So just bear with me 1 second. Okay, so we have the Git bash window open, and what I'm going to do is just with pwd, see where I am. And what I actually want to do is change into the documents directory, which is where I stored where I'm storing my application. So I'm going to do cd documents, and hopefully that's going to go in there. And then I'm going to do EI, and then to the demo area, which is the directory that I want to be working in. Now what we're going to do is we're going to clone a repository from the Edge Impulse library. So what we're going to do is we're going to type in git clone, and then we're going to copy and paste in the link that's provided in the instructions, which shows you exactly where the Edge Impulse standalone example is. And if we go back to the directory that we were just looking at, that we were working in, we'll see now that we've cloned all the software framework to work with the Sony board. What we can do is we'll notice under here the Edge Impulse. This is where we're going to put our developed application that we're going to get created within Edge Impulse. So here's what we're going to do now. Is we're going to go to deployment. And we're going to ask it to create a C or C++ library. And then we're going to go down to the bottom and we're going to ask it to build that model for us. And this is going to give us a zip file that's going to contain a nice C library. And you can see it is quite quick to build. So once we've got this, what we're going to do is we're going to save this in the same directory, of course. And then we're going to go back to that directory. We're going to extract the files. And we'll extract them into their own directory again, just so as it doesn't get too messy or complicated. And then once we've done that, what we're going to do now is we're going to take this list of all these files that we downloaded in here, and we're going to copy them. You can cut or copy them to your heart's content. We're going to go back into that directory that we've just closed, which is where we've got all of the information. Under the Edge Impulse, what we're going to do is we're going to then paste all of those in. So this gives us our example under here that we can paste in. So what we're going to do now is we're going to go back to, we're going to give it some training data. So what this is going to do is this is going to allow us to test it on our board using one of our test images. And what we're going to do is we're going to go back to this area here. We're going to find the Edge Impulse main, and we're going to double click on it to open it up. Once we've got that, you'll see here that there is a features directory, a features array for where we might want to store some data. So what we're going to do is we're just going to delete that. We're going to go back to our Edge Impulse application, and what we're going to do is we're going to go back to that live classification. And on that live classification, we're going to load the sample. And again, this time we're going to load in the sugarcane one at the top. And you'll see as it runs through, you'll see it gives you this raw features, which is the raw features that are actually put into the impulse that we've created. So we're going to click this. We're going to copy this to the clipboard, and then back in our C source code here, we're just going to, hopefully I copied that. We're going to paste that in there, which is going to give us a nice long line of data that we can put in. If we're working with an accelerometer or something, it's much simpler. But with an image, obviously, we've got quite a large area. We're going to save that, and then we're going to close this directory. Once we've got that, we're in a position that we can actually build and test this and deploy it on our hardware. So what I'm going to do is I'm going to open a command window. And in there as well, I'm going to then change into the documents area, the area that I'm doing my development in. If I can type today, so using demo, and then we're going to go into the standalone inferencing example that we've just downloaded. So this copies us all into that directory there. Once we've done this, actually, the next thing we want to do is build the actual application. So what we're going to do is we're going to do make-j, and it's going to run the make file, and it's going to run through, and it's going to build for us. We're going to run that again. Actually, I did notice it got a few errors in there. I've noticed on the second time round, it tends to have all the prerequisites built that it's needed to have. So what we'll see this time is we'll see that it's correctly written the firmware out and the application out that we want to use. Now we've got this. Now's the time to actually connect together our board and connect the board to the hardware. So we're going to take our little board here. You can see I've got mine. It's got the camera all connected for the development. And I'm going to connect this and plug this into my computer, into my development system. I'm going to make sure I connect it with the bottom line here. And then once we've got this connected, we can actually try and run this on the system. So what we can do, assuming my laptop is going to recognize the Sony board, we can do make flash, and this is going to run the flash command, and it's going to build it in, although it's not in this instance because for a slightly different reason on my computer, I have Python mapped slightly different. I have Python mapped slightly differently. So I just need to make a simple edit to the file here. If I do that, and we then run this command again, we will find all the necessary things are included, and this is going to run through, and it's going to program and restart the board. It's going to ask me if it's connected to UART COM3, which it is, and I'm going to click yes, so you can see that it's now using COM3, and it's going to install this software. Now it's using a fairly fast board rate, actually, I've noticed, of just shy of a megabit per second, which shouldn't be a problem. But if it is, and you start seeing lots of errors or lots of knacks, then don't be shy about just using a lower board rate and telling it to use a lower board rate than that one. And you can do that in the make file, just in case you happen to have a flexible cable or something. So now that's in, and we've programmed into our board, and we're all good to go. The next thing we want to do is we want to run the Edge Impulse daemon, and we're going to run this through now. We're going to hopefully you have this installed on your machine. We're going to do Edge Impulse run impulse, and we're going to give it a raw tag as well, and we're going to ask that to run, and it should see that we're connected to COM3, and you'll see what this is doing is it's running through, and it's analyzing all the data that we've just put in there in that top file. And in this example, it's a little tricky to see, but as it runs through, what we will see after a second or two, we'll let it run again. And I'm going to break the program there and just pause it. What we will see if we scroll through here is we will see that it's run through, and it's telling us the result of the classification. So it's just literally running around in a loop and taking that information that we've given it that input data there that's come from the raw features, running through that, classifying that in the example, and then giving us a prediction on what can be seen on the output. And you can see we put the sugarcane example in, and it has come out and told us that this is detected sugarcane. Now this is a really great, really simple little example that we can use in our system to run through and classify it. What we need to do now, obviously, is add in the rest of our system and work through that GPS, work through that connectivity of it, and actually do a little bit more on integrating the system as a whole. The other thing we can do, so this is actually just showing you how we can classify an example, because unfortunately I'm in my office and I don't have a field next to me of different types of things, of wheat and such like. But what we can do as well, in the deployment version that we come back to, you can actually download ready-to-go firmware. So you can just download this firmware, which will also be burnt to the board, and that will actually be using the camera to actually do live. That will use the camera. It will be doing live classifications via the camera, and it will be telling you whether what it's looking at is wheat, sugarcane, or maize. And I think that's a really simple, it's a really nice thing about the Edge Impulse, is it gives you that end application if you want to go away and do some remote testing with it. we wanted to, obviously we want to make some iterations, we want to do some more complex software development added onto this framework, around this framework that we've created, which is why the path today I've shown you is that downloading that C++ library element. You can also as well download it is possible to program the Sony S-Bench using the Arduino, using an Arduino interface and Arduino thing. So it is possible to also download a Arduino library and start working with it like that. So I'm going to leave you there. It's been a great little project to work through. I'm sure as we get the next generation robot on there, we'll continue creating this ecosystem and this solution to put it on the robot. And hopefully in a few months' time, we'll receive a little bit more funding and we'll be able to progress a little bit faster than what we have been doing and get that robot up and going. But thank you for watching, and I hope this has been interesting. I hope you get a good example of just how easy it is to create an accurate machine learning system using Edge Impulse, and how easy it is to deploy and do some testing with it.